Hello everyone, this is Mrs. N.Padmashri from SNS Institution. Today we are going to discuss about the seminar topic Face Recognition by the third year students of Artificial Intelligence and Data Science Department. So today we have Devadarshini, Bharati and Gayatri. They will be discussing about the very important application in deep learning, say face recognition. So what is this face recognition? It is a very important technology in deep learning where it mainly uses, it analyzes and it compares the face images and the videos of a person. So it compares the two images and it will identify which is the correct image. There are so many applications available for deep learning, in which the main important applications are face recognition, face detection, face extraction, deep fake detection. So today we all know that deep fake detection is a very important topic which is going on around the social medias, where nowadays the people, they are doing that editing work in the videos. So they can easily fake the video, they can change the face of a person. So how to identify all these contents? So for that we have the concept in deep learning, deep fake detection. It just take the image or the video of a person and it compares the facial features of the images and it identifies which is the exact picture, which is the correct image. So let's come, we will explore this face recognition topic with our students.
Hello everyone, we are going to take up a case study video on face recognition using deep learning. Introduction. Face recognition is a biometric method that uses the facial features to identify the verify the person. It has gained significant traction over the past. It has especially with the advanced in deep learning. Unlike traditional machine learning methods, deep learning can automatically extract hierarchical features from raw images, enabling more accurate and scalable face recognition system. This case study explores the deep learning based approach to face recognition, detailing in methodology, implementation, challenges and applications. Problem statement. And the primary object is to develop a robot face recognition system capable of accurate identify individual in real time under varying conditions such as lighting, pose and occlusion. This is the critical application in security access control, attendance system and personalized user experience.
Background and motivation. Traditional face recognition techniques such as idle faces, Fisher face and local binary patterns (NDP) have limitations in handling variations in the environment. With the advent of deep learning, particular convolution neural network (CNN), the field has seen significant performance improved. Deep learning models can learn complex non-linear mapping from facial images to feature vectors embedded highly accurate face recognition. Solution approach. The solution involves creating a pipeline that includes the following steps. Face detection. Identify localized face in the image using algorithms like NTCNN, multitask convolution neural network. Face alignment. Align detected faces to a convolution vector to improve recognition accuracy. Feature extraction. Uses deep CNN models like FaceNet, VGG face or DeepFace to generate a numerical embedding to extract each face. Face matching. Calculate the distance between embeddings using a metric such as Euclidean or cosine similarity. Faces with distance below similarity, faces with distance below a threshold or considered as match. Model architecture. Example architecture used in feature. Input layer. Accept 160 into 160 images. Convolution layer. Extract hierarchical features. Embedding layers. Outputs 120 dimensionality feature vector. Triple loss function trains the network to get the embeddings of an is closer to a positive than a negative by a specialized unit.
Tools and technologies used. By programming language used is Python. Deep learning framework is TensorFlow, Keras and PyTorch. Library used OpenCV, DIP, NumPy, MTCNN. Datasets LFW. Labeled faces in the wild. VGG phase 2, MSCLB 1, 2. Next one is data pre-processing. Convert image to GSLR or RGB. Resize the standard input dimensions. Example 160 into 160. Normalize the pixel value. Perform data augmentation. Example rotation, flipping, brightness adjustments to increase the robustness. Next one is training the model. Training involves feeding the network with the triplet of images, anchor, positives and negatives, and minimizing the triplet loss. Due to the difficulty in selecting informative triplets, negative mining is often employed.
Accuracy, percentage of correct matches, precision and recall, measure of equivalence and completeness, F1 score, harmonic means of precision and recall, false acceptance rate and false rejection rate, measure system reliability, ROC curve, trade-off between sensitivity and specificity, result and performance. Using the FaceNet model, trained on the VGG phase 2 dataset, accuracy on LFW dataset, 99.63% average embedding computation time, less than 50 ms meter per second image. Real-time recognition achievable at 20 fps on standard GPU.
Applications: security and surveillance, monitor public areas, track criminals, access control, replace password-based systems, attendance management, automate roll calls in institutions and workplaces, personal devices, unlock smartphones and computers, social media, auto-tagging and face clustering. Challenges: variability in input data, lighting occasion posts, data privacy, concerns over misuse of facial data, ethical concerns. Bias in training data can lead to unequal performance across demographic groups. Real-time constraints requires optimization for deployment on edge devices.
Scope. Integration with other biometrics. Combine faces with voice, irises or fingerprint recognition. Federal learning. Train model on devices to preserve use privacy. The 3D face recognition. Handle extreme poses and occultations. Anti-spoofing. Detect photos or videos used to fool the system. And conclusion. Face recognition using deep learning has revolution in the field of biometric identification. By leveraging CNNs and loss function like triplet losses, modern system achieve remarkable. Developers must address ethical and privacy concerns to ensure the responsible deployment. The future promises even more secure, inclusive and privacy preservation recognition technologies. Thank you.